Alright guys, today's lesson is going to be on trig identities, just giving you some practice, so more along the lines of what we did last time. What you're going to notice in this picture is this is a recap of what we did last chapter, because we're going to start actually using a lot of the cardinal directions that you see on the right hand side of your screen here. And so as I'm looking at these, I can recognize that first of all I gave you north, south, east, west. I gave you where exactly northeast would be, exactly northwest, exactly southwest, and exactly southeast. Now remember that these are all going to occur at 45-degree increments from one of the main cardinal directions. However, you see that there's a couple points, other ones in here, and these other couple points are going to signify one of these. And so we did this in the past, and that way you can kind of jot these down a little bit and see what you remember. Alright, so if I was to grab a pen, let me go ahead and we'll do, let's go with the purple. Some of you are going to be like, yes. Okay, so if I have the purple pen here, and I was to say look for this one right here, then I know that first of all I have to go over in the eastward direction and then up in the northward direction in order to create that angle. And so if I was to do something like that, then I know that, where's my selection tool? There it is. Okay. Then I know that I have to first go over east and then up north. So the way that I kind of taught you guys in class in chapter 2 was you would go first have to go east and then you would go north of east. So I would grab the north of east because this one goes right there. So if we stayed in the same quadrant here, remember quadrant 1, then if I'm looking at, say, this spike, I know that the angle that I'm creating is going to be the angle inside here or the angle inside here. So I just didn't put those little angle measurements in there. So I'd first be going north, and then I would be going east. So I would go north, and then I would go east of north. So that's where I would then have east of north as opposed to north of east. Okay. And so the reason why we're going through this is because sometimes I'm going to give you vectors, and the vectors are just going to say 20 meters at 50 degrees north of east. And you're going to have to know how to draw that vector. If you put that angle in the wrong spot, your problem is going to be completely wrong. Okay? So if I was to say look at the spike in quadrant 4, then I first have to go over east, and then I'm going to go down. Interesting. Huh. I covered up those. Okay, because I didn't want to use those ones. All right, so then if I'm going to go over and then down, that's going to be east and then south of east. So I'd be dragging south of east over here, which means then if I'm doing the other one, the angle being inside, I would first be going south, and then I'm going to go east of south. So I'm going to go ahead and grab east of south, and that would go right in there. And then if I'm going, clockwise in a circle here, the next one over, I'm first going to go south, and then I'm going to go west of south. So therefore I would drag west of south over here. Naturally then I'm going to come up here. I'm first traveling west, and then I'm going to go south of west. So your spike up here in quadrant 3 is going to be south of west. And then I'm first for the one in quadrant 2 now, I'm going to go west, and then I'm going to go north of west. So therefore I'm going to grab north of west, and that's going to go right here. And lastly, naturally, we only have one left. It's going to be west of north, and to go through it once again, you're going first north, and then you're going west of north in order to get there. So these are extremely important to remember, because what's going to happen is you're going to maybe forget these later on, and then you're going to have to remember how to draw these vectors. And so just make sure you know how to draw your vectors. All right, I was mentioning yesterday a way to remember sine, cosine, and tangent. Some of you have probably seen this before. Maybe not this exact image, but it's known as SOHCAHTOA. And so it's the chieftain of, I don't know, trigonometric identities or of mathematics. And so you can see this guy looks pretty awesome. He's like, what's up? I am SOHCAHTOA. I am awesome. And kind of looks like he has some devil horns and nice headdress and everything going off there. Anyways, all right, so When you're looking at this, we know that sine is based off of opposite and hypotenuse. And then we got cosine, and cosine is based off of adjacent and hypotenuse. And lastly, we got tangent, and tangent is based off of opposite and adjacent. So ultimately what we're looking at is, if you remember how I drew them the other day, basically I have sine of theta equals opposite over hypotenuse. And so that's like the same form for all these. So cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. A lot of times when I write this, if I'm just writing it quickly on my page, then I'll write like a big capital S, and then I'll write a little lowercase, or not lowercase, but smaller capital letters of the O and the H. And then I'll do a capital C with a little a and an H, and a capital T with a little O and an A. Or, if you wanted, you could write it as the way you would see it in the fractions. And that way you got them over top of each other. And so you can write SOHCAHTOA like that. And that way it helps you to remember that it's going to be opposite over hypotenuse. Just don't forget that there's an equal sign. A lot of people will do that. They'll write sine theta, and then they'll just write opposite or OH, or they'll write sine of OH. So just be really careful about how you write it, and just make sure you don't forget that equal sign. All right, so I'm going to go through a lot of images on this one just to kind of make sure that you understand what the opposite side means, what an adjacent side means, what a hypotenuse means, and then we're going to go through a lot of practice. So in this one, if I was, say, looking for the sine of this triangle, remember that sine of the triangle, there's my angle, so that means that this is my opposite side, and then my hypotenuse, once again, is directly across from that 90-degree angle. Okay, so sine is always going to be opposite, just depends where your angle is located. Naturally, if I use the angle up here, my opposite side would be down at the bottom. Okay, cosine, once again, if my angle is located here, cosine is adjacent. Notice that hypotenuse, once again, is still across from my 90-degree angle, and the adjacent is the other side that actually makes this angle. So you can always kind of think of it that way. Lastly, if I'm looking at tangent, tangent, once again, is the opposite over adjacent, SOHCAHTOA. And so therefore I can see my opposite side is there, my adjacent side is right here, so it's going to be the red line over the blue line. And you can see that they're color-coded right there. All right, so just kind of going through little by little. So we're going to practice first with sine. So if I was to check these, I know that, all right, we'll change that to a selection. And so if I was trying to find the sine of A, and some of these are going to work, some of these are not, because I kind of readjusted some of the text. And I couldn't change like the answering things here. All right, so if I'm looking for the sine of A, that means that this is my angle A, and so the sine is opposite CB or BC over the hypotenuse, which is AC or CA. And we can check, and this one actually works. Cool. Okay. So if I was to continue on with this discussion, we could look at another one. Let's practice, and let's do sine of C this time. So C's up here at the top, so therefore the opposite side over the hypotenuse again. So opposite is AB this time. And the hypotenuse is AC again. And so we should see that as our answer. Like I said, I readjusted and changed stuff, and so that's why the top one's no. But we all know that Mr. Schmidt should know what he's doing. If he didn't, then you guys would be in the wrong class, right? So we'll just do a little bit of a scribble here. And we'll say YES, and don't forget that exclamation point. So yeah, we are good there as we're looking at each and every single one of these. All right, cosine. Cosine, once again, you're looking at your triangles, so therefore cosine of A is going to be this angle here, and what we're going to do is we are going to be specifically looking at the sides, and so this case it's cosine, which is the adjacent over hypotenuse. So the adjacent side is going to be AB or BA, so we could place that over the top, and then I know that cosine, once again, adjacent over hypotenuse, the hypotenuse hasn't changed, it's the same triangle, and so if we check that, yep, this one works too, so these ones are good to go. All right, and that takes us to tangent. We can try one with tangent. I think this one's going to be like, I don't think so. All right, so let's try it and see. So as I'm looking at tangent of A, tangent, once again, our angle A, tangent is opposite over adjacent, and so therefore it's going to be the BC over the adjacent, which is the AB. And if we were, good to go, then that should work. All right, cool. All right, we are trucking along. All right, one more of these, I believe. All right, so if I'm looking at tangent C, C is at the top. It's opposite over adjacent, so the opposite side would be the AB, and the adjacent side would be the BC. Because remember, AC is your hypotenuse, and if we check this one, yeah, they're both good. So there's only one of them that was having errors and issues so far. Okay. So if I was to look at this, this is just kind of a setup just to check and make sure that you're doing everything correctly. And so you can kind of, with this one, I can't drag. I'm just typing stuff in, I guess. Yeah, I'm typing in. So if I'm looking at these, we're going to type in the values, solve the unknown leg using the tangent. And so if I'm saying that I want to find the tangent of F, F is 24 degrees, so I would type in 24 degrees. And then I would come over here and I would check this one, and it's DE, which in this case is the variable we'd be solving for, so that's what we're going to be doing here in a second. And then I can see that the tangent is opposite over adjacent, and the adjacent would be 5, so I'm going to type 5 in there. And so if I hit check, then it actually is going to do all the work for us, but we're going to do a lot of that work a little bit later. So to solve for DE, what you would actually do is you're solving for x here, and so if I'm solving for x, I can see 5's in the denominator. So instead what I'm going to do is I'm going to, like they did, I'm going to multiply both sides by 5. So by multiplying both sides by 5, your 5's are going to cancel, and it's going to leave you with x, and so you type in 5 times the tangent of 24. And you can type it in exactly as it has it there, or if you wanted to, you can just type in without the parentheses. I know that the TI-84s will put the parentheses in automatically, so I could do 5 times, and I'm using my phone calculator right now, so 24, and I'd hit the tangent afterwards, equals. So some of your calculators, depending, you might actually have to type in the angle first, and then hit your trig function. But for most of the standard like graphing calculators in the TI-30s and anything up above, usually it's good to go that you can just type in just as it is here. And you should get something around, oops, I'm in radian mode. You shouldn't get that. Okay, so 5 times, that's what's beneficial about checking your answers so that it makes sense. Okay. Alright, and you should get somewhere around 2.23. If I was doing it wrong and I had the wrong mode, it was coming out negative 10 or something like that. Okay, so it would be about 2 point, and it says round to 2 decimal places, which would be 23, and so we can check to see if we're right, and yeah you are. Okay, so this is kind of what we're going to be looking at in terms of solving these triangles. This is going to be beneficial and helpful for knowing what you're going to be doing, whether you're going to multiply by 5 or divide by 5. All of that. Okay, so if I'm looking at this one, I can see it says, once again, typing in the values. So we're going to look at tangent again. Tangent is the opposite over the adjacent side. So in this case, we're looking at Q this time, and Q, the opposite side, is going to be 13. The adjacent side is going to be 12. So I'm going to type in the values of 13, and let's get back over there. Oops. And 12. Apparently a down key gives me a question mark. That's fine. All right, and so then to solve for an angle, what's going to happen is you have to actually take what they're telling you here is an inverse tangent. So I'll go through that whole process in a little bit. It'll be the very last example we do today. So in your calculators, you would see that if you find the tangent button directly above it, you would see inverse tangent. And so based on the color that it is, a lot of times it's blue or yellow, then you'll hit the blue or yellow key and then hit the tangent button, and that would give you an inverse tangent. If you're using your iPhone, which you shouldn't be doing in class because you don't need to, then what you would do is you would hit the second button, or a shift in here. So there's a second button directly underneath the parentheses, and then you would hit an inverse tangent button, But before, for an iPhone, you have to put in your 13 divided by 12 and hit enter, and then you would take an inverse tangent of that, and your angle should come out to about 47.29061004263,853. So naturally, you're not going to use all those if you're using sig figs. This one's telling us to round to 2 decimal places, which really isn't sig figs, but we'll do it anyways. So 47.29. And if I, once again, hit the check, hopefully we'll get another way to go. Oh, yeah. So we're good to go. Okay. So once again, if I'm looking at a little bit more practice, we're going to actually draw in on these ones. So I'm going to go ahead and grab the pen. And so as I'm looking at these, once again, trigonometric ratios, you can see I use the same numbers from before because this is called a Pythagorean triplet. Pythagorean triplets are triangles that, once again, are right triangles, and all of the sides are integers. So you could have, the most common is like a 3, 4, 5 right triangle. And any multiple of that, you can have a 5, 12, 13 right triangle. You could have a 7, 24, 25 right triangle. So it just kind of depends. So if I'm looking at, say, the sine of theta, I can see theta is located right here. Remember that theta is opposite over hypotenuse, and so I actually have them all, labeled for you here. So I would say that this is 5 over 13. And the cosine of theta, once again, theta is here. Cosine is adjacent over hypotenuse, which is going to be 12 over 13. And the last one, tangent theta. And tangent, once again, is going to be opposite over adjacent, so I would have 5 over 12. Nice. I got a way to go. Excellent. You gotta make sure that you are feeling confident and feeling good. All right, let me move this out of the way here. All right, so if I was doing trig ratios for these, let's do them real fast. So sine of c, find c first. What is the sine of c? Okay, write it down. And actually, go ahead and see if you can do all 5. So at this point, go ahead and pause, and that way you can get some time, practice. Once everybody's ready, go ahead and unpause the video, and then you can see if you got them all right, and I'll go ahead and write them all in. All right, at this point, you should have all of yours done. And so let's see, if I have the sine of c, remember, c is going to be right here. Sine is opposite over hypotenuse, so that means that it's going to be 12 over 13. If you got that one, go ahead and give a fist pump. All right, cosine of b, it's up here. So if I have cosine b, then that means it's going to be the, not opposite, sorry, it's going to be the adjacent over the hypotenuse, which is also, oh my gosh, going to be 12 over 13. Remember when that happened before, where we did sine and cosine of 2 different angles in the same triangle? Yeah, and they came out the same value. So if you got this one, go ahead and stand up, spin 180, and then sit back down on your chair. Okay, now if you're facing the wrong direction, go ahead and get back in the right direction in your chair, because otherwise you probably can't see the board, or it's going to be a little awkward for those around you. Anyways, all right, let's take a look at tangent b. Tangent b is, once again, opposite over adjacent, so we're going to be looking at the 5 over the 12, because that's the opposite side. Hopefully you got that one right. If you did, go ahead and give a high five to the person next to you. Awesome. So you guys got to have fun even if I'm not there. All right, and cosine of c, so that means that we're looking at the adjacent over hypotenuse, so that's going to be 5 over 13. And the last one, tangent c, so we're looking at opposite 12 over the adjacent 5, so we're going to have 12 over 5. All right, so if you're able to get all of those, you should feel pretty good about yourself because you're starting to get exactly what sine, cosine, tangent are. We're going to be using these, and it's going to be important to kind of utilize all of them when we're doing our trig practice, especially when we're adding and subtracting vectors in 2 dimensions. All right, here comes the part when we're going to do some math. We're going to practice this and see how you guys do. So if I wanted to find what x is here, first of all I need to know which trig identity I'm going to use. So if I'm looking at where the angle is located, I know that the x is what side? Yeah, exactly. That's the opposite side. And that means that the 125, it's across from the 90, so that makes it my what? Awesome. Hypotenuse, exactly. So if I have opposite and hypotenuse, then that means I'm going to be using sine. So what I like to do is I like to write it in variable form first. So sine theta equals opposite over hypotenuse. And that way I don't have to worry about like putting stuff in the wrong spots. So do I know what theta is? Yes, I do. It's 25. Do I know what the opposite side is? No, that's x. And do I know what hypotenuse is? Yes. So let's go ahead and plug that in. So we got sine 25 equals x over 125. Alright, so to solve this, once again, you're going to have to multiply the 125 over to the other side. And in doing so, that's going to enable you to kind of keep x by itself. So if I multiplied both sides by 125, this is your standard algebra. You're going to cancel that out, and you'll end up with 125 sine of 25. So once again, you type that into your calculator. So 125 times the sine of 25, and that gives me about 52.8. If I was doing sig figs, notice that I only have 2 from the 25, so I could say that x is just going to be equal to technically 53, and the units in this one were feet. So I'm just going to leave it with the feet for now, even though, it irks me because it's not in meters. Alright, let's try this one, see if you guys can figure this out. So the angle here is 5 degrees. We got a value of 240, and we have this x. So if we're solving for x, I want to know ultimately how far away this boat is from land, so that it's not actually from the lighthouse. So that way it actually wouldn't come in contact, and then it would be shipwrecked. And so I can see that the 240 is my opposite side, the x is my adjacent side, and so my opposite and adjacent would give me right. And we're going to use tangent, so I'm going to write in my tangent. Tangent theta equals opposite over adjacent. So if I was to plug in my numbers, tangent of, in this case it's 5 degrees, equals my opposite side of 240 over x. Alright, now this one's kind of tricky because now the x is in the denominator, so you got to be real careful with this. What I would recommend for a lot of you is just put the tangent of 5 over 1, and that way you can just cross multiply. And so if I cross multiply, I'm going to end up with x times tangent of 5, and that equals 240 times 1, which is just 240. Alright, so now I can see kind of what I'm going to do. I'm going to divide both sides by the tan, and it's going to cancel out everything here. Naturally, there's going to be a 5 there. And so then x is going to equal 240 divided by tangent of 5. And so that's how I would type it into the calculator this time. So it looks kind of weird because normally you're not used to having a trig function on the denominator or in the denominator. So I would type in 240 divided by the tangent of 5. And it should come out to a pretty large number. If you got a large number, you're like, oh my gosh, I don't think that's right. The number should be 2,743.2, and kind of keeps on going from there. Naturally, I can see I have based on the angle, only one sig fig. We'll just leave it right there for now. That way you can kind of see that your number matches, but naturally I would round it to 3,000 if it was me. Okay, so that's how you would solve, once again, if you have your x in the denominator. All right, very last one. You can see we're on page 18 of 18 here. So if I have this, and let's say I want to know what that is. So if I'm trying to find an angle, then what I'm going to notice is this is from the angle, this is my opposite side, and this is my hypotenuse. So because of that, I'm going to use sine. So I would say sine of, let's just call it theta, equals my opposite side over hypotenuse. And so the theta is actually what I don't know this time. So I have sine of theta. All right, equals opposite. The opposite is 15 over 35. All right. Now I see I have both numbers over here, so I could actually divide that if I wanted to. But the question is, how do I actually solve for theta? And so here's what I'm going to kind of go through with you guys. All right. So if I had, and I'm going to make this really hard for you, if I have x minus 2 equals 4, and I said solve for x, how many of you guys could do that? Really? Only a couple of you? Okay, that's a little better. All right, so if I'm looking at that, I know that x minus 2 equals 4. So if I was to add 2 to both sides, then I would get 6. Excellent. Now, what you're actually doing is you're not just, adding 2, but what you're doing is you are adding an inverse, because the inverse of negative 2 is positive 2. So what this is called is an additive inverse. And so by doing that, you can see that the 2 and the negative 2 would cancel, and I would end up with x equals 6 here. All right. However, if I was to look at multiplication instead, let's say I have 3x equals 12. I know, I got even tougher on that problem. So if I have 3x equals 12, how many of you guys could actually solve that one? That's it? Really? Oh, come on, guys. So yeah, you guys could definitely do that. So if I was to solve this, what I would do is I would actually multiply both sides by 1/3. And some of you are like, that's not what I would do. I would just basically divide by 3. But ultimately, we are doing the same exact thing. And so what this is called is a multiplicative inverse. And so a multiplicative inverse is, once again, taking the inverse. You'll notice that it's a reciprocal of our number, and so a lot of times that's what we're doing. You guys typically think, all right, I'm dividing by 3, but really what you're doing is you're multiplying by 1/3, and then this would end up giving me 4. The key here is, though, that this is called an additive inverse, this is called a multiplicative inverse, and this is called an inverse trig function, or an arc trig function, which is what you're going to see. So if I wanted to get rid of that, I use an inverse to get rid of it. So therefore, if I wanted to get rid of sine, what I'm going to do, and I'll actually, we'll rewrite this. So if I wanted to get rid of sine, I'm going to write sine theta equals, and I'm going to leave a space, and I'm going to write my 15 over 35 right here. And so what's going to happen is I am actually going to take an inverse trig function of both sides. So I'm using my inverse again. So I'm going to say inverse sine of this side. So you can see that this side kind of looks normal now. That's what we would actually type in the calculator. This side, on the other hand, I got this inverse sine of theta. So here's what I want you guys to do. In your calculators right now, go ahead and type in the inverse sine, parenthesis, of the sine, parenthesis, of, let's do 30. And what do you get? So I will do it too, just to make sure that I picked a good number. But I'm pretty sure I'm fine. All right, so if I did the, I got to do mine backwards. 30, so the sine of 30, and then I take an inverse sine of that. And what do you guys get? Nice. Yep, exactly. So you get 30. Well, that's weird. So ultimately what's happening here then is my inverse sine and my sine cancel out when I take one of the other, and I'm left with what is called the argument here. So if I take an inverse sine of sine, then that should cancel things out and leave me just with theta, and that's kind of what happens. So go ahead, let me go ahead and erase all this stuff. So let's get rid of this, and let's get rid of this up here. Alrighty, let's go back to my pen. Okay, so ultimately what's going to happen is my inverse sine is going to cancel. my sine, and I'm going to be left with theta on that side equals just the inverse sine of 15 over 35. So that's what I would type in my calculator. So I would type in mine, I got to once again type in the 15 over 35 first because I'm using the phone. And then I would take an inverse sine of it, and mine gives me a value of 25, and I'm going to round it, 25.4, and this would be feet since I see the hypotenuse is in feet. Oh, never mind, it's not feet. This is an angle. Shame on me. What am I doing? Okay, so I'm going to go ahead and erase feet here. We're actually going to put in the angle and also the cardinal direction, so this is going to be cool. So 25.4, this is 25.4 degrees since you should be in degree mode. And if I did the cardinal direction, I'm first traveling, nice, west, and then I'd be traveling, excellent, north. So this would be 25.4 degrees north of west. That's better. All right. So that kind of closes out looking at and practicing trig identities. You're going to see a lot of these concepts that we are going to cover tomorrow. So therefore, you guys are good to go for today. Take a break, and then tomorrow we're going to go through adding vectors, and you guys are going to need to grab a homework tomorrow as well. And then that'll be due based on the schedule you have on your schedule.